Morning, everybody. Pretty good for 9 o'clock. I'm pretty impressed. I won't actually make you say it again. That was so good. On a Thursday at 9 o'clock. Well, thank you for coming. My name is Mark Russinovich. The reason that I put this up here, by the way, is because we have the first case of the Unexplained to deal with right here, which is this is the Ignite conference session guide, and it says that I am going to be talking about database migrations. So I've never done that before, so let's just keep your expectations low, and we'll see if I can get through this. Just kidding, of course. Raise of hands. How many people have seen a Case of the Unexplained talk before? How many people have not seen a Case of the Unexplained talk before? So welcome to the new people. I think probably a lot of new hands here because this is now a combination of multiple conferences, and so we've got some people here that traditionally haven't been at TechEds and seen Case of the Unexplained. So we also know that there's some people here that are first-timers for a Microsoft conference, so welcome, and I hope you're having a great conference. Now, the reason that I'm giving this talk, I'll explain in a second the introduction. I want to give you an outline of what I'm going to be going through this morning in the next 75 minutes. I'll start by setting that context, and then I've broken down some cases into different categories based on the symptoms. And we're going to take a look at those cases and address them, talking about sluggish performance, error messages that you run into, buggy behaviors, so just applications behaving in an unexpected, undefined way, and then we'll conclude with a look at blue screens. Now, the reason that this session exists is, well, I'll have you answer the question. How many people have seen an error dialog box that had no information and no help about what was actually going wrong? Okay, so that's ever. How about in the last day? So usually get a few hands there. The problem is that most software developers are focused on the expected code pass through their programs, and they focus their energy on making sure that they have that right and that the features work correctly. The problem is once their software gets out into the real world, it starts interacting with other software. It starts interacting with systems administrators that are locking down systems. It starts interacting with uninstallers and other add-on software that think they're doing a good job of helping a system remain stable when in fact they're causing problems. And whenever a piece of software, whenever a code flow runs across a case that the programmer didn't code for, you get some unexpected types of behavior. For example, if the program expected to find a file in a certain location and the file was missing, but the programmer didn't check to see if the file was actually there, that might throw an exception or return an error code that the program doesn't check for, which causes it to continue on executing as best as it can, and it will run into something else and eventually will throw up a dialog box on some other error that did check for that has nothing to do with the root cause, or they'll end up crashing, or they'll end up hanging, or they'll end up consuming excessive cycles of the CPU while they're sitting there looping on some variable that was uninitialized. I actually have run into, just like you, many dialog boxes that have absolutely no information, no helpful information about what's really happened. And I've got some favorites of mine here. This is one of my favorites of all time. This is from Outlook, and you can see this is fairly recent because it's got the new look on it. My favorite part of this dialog box, of course, is this part right here. Here's another one, which is a Visual Studio one saying that the project is in a zombie state. So it's the Visual Studio Zombie Apocalypse. And then the worst, most horrific dialog box ever is this one. So these are just some examples of the things that we all run into. What I'm going to do in this talk is to let you look underneath the hood of what's going on when those programs are throwing those dialog boxes and maybe give you a way to figure out what's the root cause that led to that dialog box where the dialog box isn't being helpful, or the hang, or the crash. I'm going to show you how to interpret process activity, how to interpret registry activity, how to watch real-time what the process is doing, how to look at call stacks, which is a very powerful troubleshooting technique, oftentimes leading you to a root cause when the actual operation doesn't give you the information necessary to understand what is really responsible for a problem. The tools that we're going to use, obviously lots of from Sysinternals. How many people have never been to Sysinternals? Just to raise a hand if anybody has not been to Sysinternals yet. All right, for those of you, everybody's visited it. I don't know what your most recent visit is, but here's the site. Just to give you a quick background here. Sysinternals is something that I founded in 1996. I can't believe it's been almost 20 years. I still work on it. It's a hobby of mine. I'm the primary author. I update the pages live. I continue to work on it, so there's updates that went out just a few weeks ago. Here you can see that I pushed out some of the tools. I do now work with collaborators. Bryce Cogswell, the co-founder of Sysinternals, retired from Microsoft about 4 years ago, so I've been solo basically since that. But I do it because it's a lot of fun, and I love coming out and sharing this kind of information with you guys and helping you solve your real problems. Everything on the site is completely free, of course, and the site has about 70 tools. There's our sampling of some of the tools that I've included in this Case of the Unexplained as well as previous ones, because I've delivered numerous Case of the Unexplained talks over the past 10 years or so. There's another tool here that I use in this presentation. It's called WinDebug. WinBag is affectionately known. This is a debugging tool for Windows utility, which developers use to analyze crash dumps. And I'm going to show you that analyzing a crash dump and root causing it, specifically in the case of blue screens, is actually relatively straightforward. And that's also a free download from that site right there. One of the things I want to tell you right up front before we get into the content is if you're interested in learning more about the tools as we go through here, I mentioned that I've got a bunch of Case of the Unexplained. If you go to Mark's webcasts on the Sysinternals tool site, you'll find links to the recordings of previous Case of the Unexplained. Every one has different examples in it. All of the examples are from the real world, either my own problems or ones that are sent to me. And every Case of the Unexplained is a completely different set of examples. The definitive guide on using the tools is here, the Sysinternals Administrator's Reference. You can see that I wrote it with Aaron Margosis. Actually, he wrote most of it, so that's why I put his name on the cover. I did help with that. We're writing a second edition. This one is a little bit out of date now because it's missing some of the most recent tools and the features, but it is in the bookstore, so I recommend that you buy it, and don't wait for the next edition, which is probably going to be out in 3 or 4 months. Just go ahead and buy both of them. I'd appreciate that. Now, let's go ahead and get started. Let's talk about sluggish performance. Now, this case is an embarrassing one. Was anybody at TechEd Europe in October, by any chance? And anybody come to the Case of the Unexplained talk that I gave there? So you saw this live. Let me go ahead and play this for you, because this is what happened in that presentation. 9 months or so. One of them is run automatically at logon. So in the past, you'd have to, if you wanted Process Explorer to always be running, where'd it go? Process Explorer. If you wanted Process Explorer always to be running, okay. That's not something I deserve applause for. I don't know. It's got to be a network problem. So I didn't debug that situation right there, but I did afterward debug it. And so let me talk a little bit about Process Explorer, which is the first tool. And we're going to show Process Explorer in the context of troubleshooting a little bit later, but let me just give you a quick guide through Process Explorer. And this will be a refresher for some of you that are already using this on a regular basis. For those of you that are new to it, this is a primer here, a very basic primer. First thing that you're going to see is that it is like Task Manager, except it's much better than Task Manager. That's one of the things you'll first see. It shows you this process tree, which reflects the parent-child relationship between the processes, which is useful for understanding the lineage of a process and also what its purpose is. Lots of times you'll find some third-party software that launches a bunch of child processes, and it's very easy to see that those are related to that primary launching application just through looking at the process tree. Here we can see, for example, services.exe, which is the service and control manager. And this is what is launching the background processes or the system services in Windows. Anything that's a direct child of it typically is running or hosting Windows services. So this service host right here, a child of it, is going to be launching Windows services inside of it, and then those services then are launching children themselves. If you look down a little bit further in the process tree, here's Explorer, which is the shell process, which is what was launched when I logged in interactively to the system. and then a bunch of processes were launched from Explorer. Another thing that you'll see is that you'll see CPU, private memory, and working set. These are virtual memory counters, how much virtual memory the process is using, and how much physical memory the process is currently allocated or assigned by the memory manager. Then you'll see a description and company name column, and these columns have information that Process Explorer pulls from the version information that the developer has placed in the binary. So it's not some database, it's coming out of the executable itself. You'll see that there's a number of different colors displayed here. Those of you that came to the malware talk know that the blue processes are boy processes, very good, boy processes, and the ones that are pink are girl processes. And sometimes they mingle together. You can see here there's some blue and girls and boys playing together nicely. Actually, they're not really that. Just wanted to get that clear. The blue processes are ones that are running in the same security context as you when you log in, or Process Explorer, whatever you launched it in. So you can see that's why Explorer, well, Explorer is a different color. But everything that is a child of Explorer is blue because Explorer did originally launch at me. There's another color highlight here that is in play on Explorer, but let me come back to that in a second. Just talk about the pink are processes that are hosting Windows services. So that's why we saw that service host highlighted in pink. Any process hosting a Windows service will be that color. Explorer is this cyan color, and that was introduced in Windows 8. And these kinds of processes are Metro, Modern, Windows 8 App, Windows App Store, I don't know what we call them anymore. App Store, Modern Metro apps, I don't know. They're something like that. And they are able to display them, interact with the modern start menu, the start screen. So that's why you see those in cyan. Anything that is white doesn't meet any of the highlighting colors. So there are a number of other ones. If you've got another user interactively logged in, processes are likely going to be white because they're not going to match any of the other highlighting, and they're not running as you. The other thing you see here as I move the mouse around is a tooltip. This tooltip shows us information about the executable that's easy to access here. You see the command line, you see the path to the process. In the case of something that hosts something inside of it, like let me give an example. This thing, well, I'm supposed to see a little dialog box pop up here. There it is. This thing that I just opened, date time, if I drag the window finder, actually there's a bug in Windows 10 shell there. If I drag the window finder over it, it'll take me to that process, and you can see that this is run DLL32, and you can see that it's hosting the time date applet. And this is the DLL hosting that little clock or that time date setting that we see there displayed in the GUI. So this run DLL is just a hosting process, but you can see what's hosted inside this run DLL. Similarly, if you go up to service host, you can see the services that are hosted inside of a service host. This particular one has background task infrastructure, the DCOM server process launcher, the local session manager, and so on. There's more detailed information you can get about a process by clicking on the process, double-clicking on the process, and taking a look at it. So you can see, for example, that this is Windows Explorer. You can see which version it is. You can see when it was built. Here's the command line again for convenience in the current working directory. If it auto-starts, here's where it auto-starts. Now remember I mentioned that the shell, this is my shell. That's how this is configured as my shell. You can see here the parent, the start time of this process, whether it's 32-bit or 64-bit, its DEP and ASLR status. You can also verify digital signatures. So if I press verify, you can see that this thing is verified to be from Windows, from Microsoft. And then there's additional tabs that are very useful for performance troubleshooting. So this tab shows you counters for CPU, I/O, virtual memory, working set or physical memory, and handles, both GDI and kernel object handles that the process has open. The performance graph shows you a history, and these graphs show you the I/O history, private bytes, which is virtual memory, and CPU usage. There's disk and network activity, there's GPU usage, there's open TCP/IP ports, security settings. These are the groups and privileges that I belong to, or the process belonged to at the time it was started. So there's something called a token that represents that, and this is dumping that information. So you can see that when this process goes and interacts with objects on the system, it's doing so in this security context. So if there's a group that it belongs to, then that's going to be checked out of the information shown here. The environment variables that the process is going to read, and then strings, which is showing you the strings that are in the executable image itself. And this is useful for malware hunting, so I'm not going to dwell on that one. The threads tab shows you the threads that are in the process, and this can be useful if you have a process that's running out of control and you want to see if a third-party DLL happens to be causing it to run out of control. This is pulling in debug information from the network, so this is going to take a second. While it's doing that, why don't I do? Network is not behaving. Hopefully I don't have to debug this one too for you. All right, I've been meaning to make this dialog box asynchronous. The problem is that this is a new build of Windows, and so lots of these symbols aren't on my system right now. And so I'm going to, unfortunately I'm going to have to do an ugly thing here just to move on. If I could run Process Explorer, I'd kill this. Here, let's just do this. Sad. And then let's launch again. It looks like my shell, something's wrong with my shell. Okay. All right, Windows 10 shell is not behaving. That took care of that. There's another tool for you. And it looks like Explorer's. All right. I've really kind of screwed up my system at this point because I have no start menu. Okay. Well, yeah, this is going to be an interesting presentation. All right. Let's just try going from PowerShell. You can do everything from PowerShell, by the way. Okay. I've got myself into a hole. It is unexplainable. All right. Let me see if I can start Explorer from here. There we go. All right. Now. Whew. All right. We're back. All right. And where'd Process Explorer go? Hey. All right, so where was I? I was taking a look at some of the tabs here. And I think that's enough of that. You get an idea for the tabs. Now, one of the things you can see here is system information. I'm going to open that up, and hopefully that will behave for me. Great. Let's go back to the slide deck. You know what? This is pulling in symbol information too, so that's my network connection must just not be working. Okay, so one of the things that you can do, which I do, is I set it so that Process Explorer, there we go. Process Explorer always shows you something in the taskbar in the tray, which, okay, Explorer is not showing it in the tray. But what you would normally see is a little icon there in the tray that shows you the CPU usage, and you can add the other little icons there to show you memory usage and GPU usage, whatever you're interested in seeing there. By default, it's GPU, and I always make it visible so that I can see when something starts burning the CPU that I'm not aware of that might be killing my battery life. But if you want to take a look at overall system performance history, this is the tab to look at. Summary view of system performance across a bunch of different vectors with graphs. There's a tooltip that shows you the time of the particular place in the graph that you're looking at. And for CPU, it'll show you the biggest consumer of CPU usage at a particular point in time. So here we see a little spike there, and it looks like Explorer, or actually Anti-Malware Engine was doing a scan at the time. At the same time Explorer was consuming CPU, at the same time Process Explorer was starting up and consuming CPU. So that's what explains that spike right there. You have CPU, memory, I/O, and GPU. So those are system-wide graphs. Now, by the way, so there's some other features that you get with Process Explorer. One of them that I find very useful is suspending processes, and I showed that in the context of anti-malware or malware yesterday, where you can suspend processes. For example, I can say suspend, and that will make this process gray and suspended. And the reason I'm showing you this dialog box here is that I was downloading from MSIT, was downloading Windows 10 Enterprise Technical Preview to my system, consuming a lot of network bandwidth and killing my disk while it's writing to disk. So, and I wanted to get some work done, so I just went to Process Explorer, and you can see I suspended it right here. And that kept it out of the way. When I was done and ready to walk away from my system, I resumed it, and it continued on its merry way, downloading out of my way. So that's a quick look at suspend. By the way, here's the new Windows 10 Task Manager, which I'm really excited about. This is only in the enterprise SKU, not in the consumer SKU. There's a bunch of new features that I've added to Process Explorer over the last year or so. One of them is that you can run it now at logon. So this is what I always do now is go configure that to run at logon. Every time I log in, it's going to be sitting there in my tray. And if I did do that when I elevate it, it's going to automatically launch elevated and without a UAC prompt at the beginning of my login session, so I don't have to worry about that. It shows you WMI provider host. So the WMI provider process is another hosting process. It shows us Windows 8.1 DPI awareness. So this is especially relevant as these screen resolutions become extremely high. Developers need the program to be DPI aware and flag that to the operating system. So that I added at the encouragement of the Windows graphics team. And then it also shows you the protected process state of processes, which is interesting to see what kind of code can run inside of a process. And this has been fleshed out over releases of Windows. So if I go and select protection, you can see there's a number of processes that restrict what kind of code based on digital signatures can run inside them. The CSRSS is one example. The anti-malware engine protects itself as well with a signing policy for what code can run inside of it. I have also integrated with VirusTotal and anti-malware as a service. Those of you that came to the malware talk yesterday saw this, and this is great for malware hunting. I'm not going to spend time on it here, but be aware that if you didn't see that you can go and add a column and have Process Explorer automatically upload all the binaries in the processes or the DLL view to this online scanning service and show you the hit count of the number of antivirus engines that detect the image as potentially being malicious. And that's useful for, of course, checking for malware. So that's a quick tour of Process Explorer with a little bit of digression into trying to get my shell started again. Now, back to where we started with, which was that presentation that I was doing at TechEd Europe, where Process Explorer hung on me, and in that case, it really was a bug. Fortunately, I had a tool that running, a Sysinternals tool that I co-authored with Andrew Richards that collects crash dumps for any crash. And so I had a crash dump of that very crash. Now let's take a quick look at what proc dump does. How many of you have ever had a situation in your network where you've got a server application that has spikes of CPU or memory, and by the time you get to the system to take a look at it, it's back to normal? And so you've got a non-reproducible situation, but you've got end users complaining all over the place. This is why I wrote this tool. It was specifically for the Exchange team, where they had Exchange would spike in CPU usage, users would have trouble logging in, and by the time they got there, of course, the problem's gone. So the first thing you can do with proc dump, and the first feature I added to it, was a trigger where you could say, create a crash dump if this process exceeds a certain amount of CPU usage for a certain duration. I'm going to launch a little tool here called CPU stress that does that. And then we'll do proc dump -c and CPU stress. And I'll make the dumps go to this directory right here. Whoop. What am I doing wrong here? What? This is just demo nightmare this morning. What is going on here? No, I shouldn't. Yeah, I shouldn't have to set a number here. Oh, all right, fine. So this is saying if the process exceeds more than 50% of the CPU, by default it should just say 25%. Actually, I forgot this does require a specific number. I'm going to make it exceed that amount of CPU here by making this thing be busy. And you can see that when I delete that or when I disable that thread, it goes back below. By default, after 10 seconds, it's going to generate a crash dump. And so this is the canonical example of getting exchange when it's spiking the CPU. But over time, I've added, with Andrew, a tremendous number of additional triggers and functionality. You can set time dumps. So you can say, I want a dump of this process every 5 seconds for the next, and create 10 dumps. Or I can say, create a dump if it exceeds a certain amount of memory usage, or if it falls below a certain amount of memory usage. So you can do above and below triggers. And you can also specify arbitrary performance counters. So you can say if Exchange, for example, or Active Directory has a performance counter that signals that it's a particular problem, you can say if that performance counter rises above a certain threshold, generate a dump. So lots of different ways to create crash dumps. You can also set it to create one on demand. So if I just said CPU stress with no parameter, then it's just going to create a dump on demand for me of that process. It supports reflected dumps. It supports the reflected type dumps, mini dumps that are supported in Windows 10. It has a mini dump plus type format dump, which collects a lot of information useful for .NET crash dump debugging. So lots of additional functionality and power in this tool. The way that I install it on my system is I do this, proc dump -I. And this installs it as the default unhandled exception debugger for the system, so that any process that crashes where the crash is not handled by something else ends up being caught by proc dump, which then will save a crash dump to the directory you specify. And by default, it'll put it in C:dumps. So that's the way I run my system, and that's the way I had it running at that day on at TechEd. So I've got a crash dump here. If I go to case of and I go to Process Explorer hang, there's my crash dump. I'm going to launch the Windows Debugging Tools utility to take a look at that crash dump and show you how I was able to figure out the problem. So I open the crash here, case of Process Explorer hang. And one of the things that you want to do when you get one of these kind of crashes or hangs that you get a crash dump on is this open the process and threads dialog. Actually, first thing you want to do is go configure symbols. So you set the symbol path, and this is WinDebug should just have a button that says set this, because this is what 99.9% of the world needs to set it to, which is to say I want to point at the Microsoft public symbol server, where it's going to pull down symbols on demand for any of the system binaries, Windows binaries and even Microsoft product binaries. And so that will help WinDebug show you function names for anything that ends up being in one of those system binaries. So that's the first thing you want to do, and that's as simple as it is to set up WinDebug once you launch it. Here's the list of processes, or threads rather, in the process. Process consists of multiple threads, almost always, each doing their own thing. And what I did for this particular case is I went looking through the threads, and then I found this. I found this right here. And I double-clicked on it. I've got the source code here. This thread is sitting here waiting right here. So the blue line is the next line that the thread would execute, but it's waiting on this enter critical section. So Process Explorer has some synchronization so the different threads don't step on each other. This is a critical section protecting one thread from accessing the same data as another thread at the same time. But in this case, this thread is stuck waiting for that. And that means some other thread is stuck inside that and owning that critical section. So which thread is owning that? So I go clicking through here, and I find this other thread right here. Right here. It's doing a send message to the main window thread, but up here I notice that it has acquired that same critical section right here. And if you see, this is in the security dialog box, the tab of that properties dialog that I was showing you. So what I'd done in the TechEd presentation is I'd left Process Explorer with the security tab in the process properties open. I'd come back to it and clicked on a different tab, or closed that dialog box, and that caused this code to fall in here, where this thing was sending a message to a main thread responsible for opening the dialog box, and then got deadlocked on that other thread, which was doing security, updating the contents of the security dialog box. So I know that this is a little bit technical for you guys, for a lot of you that haven't done debugging like that, but I wanted to prove to you that that crash at TechEd Europe, I did fix it. So if you were concerned about the stability of Process Explorer, rest assured, that bug is fixed, and I solved it with this other tool, ProcDump, being there to catch that crash as it happened, so I was able to debug it after I got on the airplane on the way home. Let's talk about error messages now. I've got a bunch of cases of real-world error messages being solved with the Sysinternals tool, and the first one is this one right here. Has anybody seen this one, by the way? Can't install Office? Has anybody still stuck on this one? Okay, so this one somebody sent in to me. They experienced this dialog box right here. Couldn't install. We're sorry, we have a problem installing your Office programs. Your internet connection working? Yes, it was. Do you have enough free space? Plenty of free space. Please try installing again after you've checked the above. They try installing again, same problem. Try installing again, same problem. And after 10 or so times, you kind of think, maybe this isn't going to work after all. And that dialog box is telling me to waste my time. So what you want to do at that point, and what he did at that point, was take a look with Process Monitor at what was going on. How many people have used Process Monitor? How many people have not used Process? That's quite a few. It looks like it's a lot more usage than I've seen before. How many people have not used Process Monitor before? So just a handful. Process Monitor is the #1 Sysinternals troubleshooting tool. Out of all the cases I've got, 90% of them are solved with Process Monitor. Process Monitor solves everything. I mean, I've got it right now trying to solve the drought in California. That's how powerful Process Monitor is. It really is one of those, there's no way Process Monitor will lead me to the cause of that problem. And you run it, and sure enough, there's a clue somewhere in the trace. It's become, it's so versatile at solving problems or leading you to solutions that Dave Solomon, my co-author on Windows Internals, came up with that slogan right there, when in doubt, run Process Monitor. And if you've come to this session before, you know that that is the one key takeaway from this session, is when in doubt, run Process Monitor. And to really help us internalize that takeaway and remember it, let's repeat it together. Okay, ready? Yeah, now we'll do it now. And then I'll prove it to you that it's worthwhile after a few of these cases. But just trust me right now. 1, 2, 3, when in doubt, run Process Monitor. Okay, that was pretty good, but I'm going to show you and prove to you just how awesome it is here in a second. Here, let's fire it up and take a look at what it shows us. Process Monitor. So when you launch it, by default, it just starts capturing information. Everything that is going on in the system related to process and thread activity, DLL loading, network activity, registry activity. And you can see that even on a clean system, where I'm really not doing much except for showing you a PowerPoint presentation, there's a ton of activity. We've got now 146,000 events shown, 500,000 events total. There's what's called a default filter in place that's hiding a lot of the trace information that's generally not relevant for most troubleshooting cases. And I'll show you what that filter is here in a second. But tremendous amount of information. And what is it showing you? Let me stop this, so stop collecting things. It shows you these columns by default. The first one is the time of day. So obviously the time of a particular operation. And for each operation, it shows you the process responsible for the operation. Kind of like Process Explorer, it will show you a tooltip here that will show you the company that made it. So this is from the version information, as well as the path to the executable and the description of that executable. It'll show you the process ID. It'll show you the operation. So this is a search indexer that's reading from this file right here, mssearch.dll. It'll show you the result of the operation, and you're seeing a bunch of successful operations here. And then for the particular operation, it'll show you detail relevant to that operation. In the case of a read, it's going to show you the offset into the file that the read occurred, the length of the read operation, the I/O flags that were passed by the process as it was executing that I/O operation. In this case, it's saying it's a non-cache paging I/O. For registry operations, it's going to show you the registry value that was queried. For TCP and UDP activity, it's going to show you the network endpoints in the path column of the source and destination if it's a TCP operation. You can, now, there's so much information here. The key to really becoming adept at using Process Monitor is filtering. And there's a number of different ways to filter depending on the situation. So let's quickly review the ways that you can do filtering. One of the quickest and dirtiest ways is, let's say that I only wanted to see, I came across this audio DG, and I said, what is audio DG doing? It's something that I want to investigate. I just want to see audio DG. So I can right-click on audio DG, and here are what I call quick filters. I can include that in the display. I can set an exclude filter, so remove those from the display. I can set a highlight, and I can copy that to the clipboard. I can also do something called edit filter, which I'll show you in a second. I can exclude all the events before this. Let's say this is the first interesting place in the trace. I can just say exclude everything before, so that's not bothering me anymore. Exclude everything after. When I say include audio GG, it applies the filter, and now I'm just looking at audio GG. Let's say I just wanted to see read files from audio DG. But I don't want to see audio ses. I'll say exclude that. And so I've narrowed down the trace to just a handful of operations now that might be exactly what I'm interested in. These are non-destructive filters. So these are just visual filters. If I say Control-R, I remove the filters and put them back to their default. So that's the quick and dirty way. Now, one of the most common scenarios is if I've got a process like Notepad, and Notepad is the thing that I'm interested in. What did Notepad, well, let me actually turn back on the filtering and do that again. What if it's Notepad that I'm interested in? A couple ways that I can zoom in on Notepad. One, if it's got a window, is drag this window finder, just like in Process Explorer, and I've just set a filter for Notepad. If we look through this, we can see Notepad starting up, and we can see Notepad eventually reading its registry settings. Let's say that we only want to see Notepad's registry settings. I can set class filters by removing all the file activity, all the network activity, all the process activity. Now I'm just seeing registry activity. And if I search for font, I'm going to find the place where Notepad reads its font, and that's where it stores it right there. So I've very quickly zoomed in on, hey, where does Notepad store its font? Right there, just by a few clicks of filtering, and I'm down to just those operations that I'm interested in. Another way that I can zoom in on a particular process, let me clear the filter. Let's say I'm somewhere in the trace, Notepad doesn't have an active window. I want to just zoom in on Notepad. What I did is type Control-T. You can also go to the Tools menu and select Process Tree. And this is a process tree very much like Process Explorer's. Parent-child relationship shown, description, image, start time, end time, company name, who's running it, and the command line of the process all shown here. This includes both processes that have terminated as well as ones that are still running. So if I exit Notepad and reopen this, Notepad will still be in this display. And if I come down here, where's Notepad? There it is right there. It's grayed out because it's terminated. And if I say go to event, it'll take me to the first event of Notepad's life there, the process start. If I say include process, now I'm back to just a filter on Notepad. And one of the useful things that you can do, let's say that I'm interested in everything under a particular subdirectory. Like, I just want to see everything under my profile that Notepad happens to be doing. I can say edit filter. Now this opens the complex filtering dialog box where I can set all sorts of expressions on all the field values that Process Explorer collects for every operation. So when I drop this down, you can see that there's architecture, or authentication ID, category, which I'll talk about, command line. I've got path here because what I've done is edit filter by right-clicking on the path, and it pre-populated path is users mark Rus. This is a conditional expression here. I can say begins with, and now if I say add, and by the way, here's where I said include or exclude. I said add, and I say OK. Now I very quickly am able to see all of the operations that are in the mark Rus directory that Notepad has performed. So that's another very quick way to zoom in on, hey, everything underneath this part, or just start with some value that's there and then be able to modify it in that complex edit filter. So that's a quick look at filtering, and that is the key to mastering Process Monitor, is getting used to those filters so that you can zoom in on information. Let's pull up the presentation again and come back to this case of the failed Office install. And let's go take a look at the failed Office install log file and see what this particular user saw. So at the end of the dialog box, after he got that error message, he exited the dialog box and he went back to Process Monitor's trace. So what we're seeing here in the trace, I've gone to the end of the log, is that Office installer terminating, and it's cleaning up. It's closing handles here. Reg close key, threads are exiting, and he's scrolling up from the end, because when you run into an error like that at the very end of the execution, go to the end of the log file and work your way backward, because you're going to be closer to where the problem was rather than all the way at the beginning of that process launch. And he saw this. He saw the setup there closing and writing to this log file right here. So he said, oh, maybe there's something interesting in that log file that I can take a look at that might give me a clue as to what's really going on behind the scenes. So here's an interesting example where Process Monitor didn't tell him what the problem was, but gave him a clue where he could continue investigating and maybe find out what it was. And here's where he went from there. Here's the log file. And you can see that it's click to run. And if you scroll down, you see a bunch of file download errors. Download failed for blah, 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 this URL. You can see try 1, try 2. It's trying many, many times. Very persistent. And error code 30125 is what we saw there. The first thing he did is said, wait, does this URL, is that a broken URL? Maybe that's what is going on. So he did this. Copy. Went to the browser. Clicked it in, and look at, sure enough, that's a valid URL. There it is. So it's not the URL that's the problem. So what's the problem? Well, he saw that error code 30125 here, and so he did a search. Oh, crap, did I just close Internet Explorer? I didn't mean to do that. What he did was do a search, and here's what he came across. We would have gone to that page right there. He saw this in user group. He saw installing Microsoft Office through Office 365. Here, although the proxy was configured in the control panel, I had to enable proxy via an elevated command prompt. Type this. So he went and typed that, followed those instructions, ran the installer again, voila, problem solved. So that sequence of events, error message that he couldn't work past, Process Monitor, looking underneath the hood, sees that the thing is dumping a log file, opens the log file, finds an error code, does a search for the error code, workaround right here that got him past that problem. So Process Monitor saves the day. Here's another example. This one was sent to me by somebody at Microsoft. This is, how many people are familiar with Emmet, the Enhanced Mitigation Exploit Toolkit? So this is a powerful tool for locking down software that might be susceptible or vulnerable and adding extra protections on top of it. This case, after the user upgraded the toolkit from version 3 to version 4, they started getting these application configuration crashes. You can see there's some .NET exception being thrown here, and the tool is broken. So at that point, he went to Process Monitor and collected a trace. I've got a repro of the similar type of problem here. Here's what should happen when I run this GUI tool, I should get an elevation, and then I should see a dialog box like this that lets me configure what I want. But I've screwed up my system in a similar way to the way he had his system messed up. And let's go see if we can figure out what the problem is by watching what's going on in procdump. So when I say launch it here, first of all, instead of launching and getting UAC prompt, I get the installer for it has launched again. So I don't know why the installer is launching, and this is, again, checking a network connection that's going to time out here in a second. And then we're going to see this thing end up crashing. And Process Monitor has already captured enough information to understand why this is not behaving the way it should be. The behavior is a little bit different because this is a different version of Emmett than what he had, and the system I've configured a little bit differently, but there's the CLR exception. So what is going on in this case? If I press stop, what he did at this point is he wanted to see if there was any results, any operations that had unusual behavior. Well, what's unusual behavior? Most cases, operations are successful. There's a lot of operations, though, that in a working system are not successful. They have results that are not successful. So if we scroll down, we see buffer overflows. Those really aren't security errors. Those are usage of the API where the caller can pass in a buffer and get back the size of the buffer that it's supposed to allocate to fit the data that's coming back. So a legitimate kind of successful operation there. But one of the error codes that is most often related to a problem is access denied. Many situations where you get an error dialog box or buggy behavior is because the application couldn't access what it needed to access. And the way that you can check for access denieds very easily, or any unusual error codes, is to go to this count occurrences in the tools menu. This lets you count the number of items, unique items, in the trace for whatever value you're interested in. So I can see the count of the command lines in this trace. This will show me all the unique command lines in the trace and the number of operations for each that had a hit on each one of those command lines. The one for the results is the one that we're talking about. And when I do a scan for unusual results, you can see access denied. There's 336, which is a very high count. If I want to see where the access denieds are, I can simply double-click on this, and that's another way to set a filter. And when I go take a look, I see I come across, hold on, a bunch of access denieds on a key here, Emmett GUI under, let me see if I got zoom in here, under current Windows NT current version file execution options. And then Emmett GUI access denied. So there's something wrong with the permissions on that key that is causing Emmett to not be able to do what it wants to do. And if I go and take a look at that key, and typically what you'll do in a situation like this is go take a look on a working system what the permissions are, if you happen to have a working system, and then take a look at and compare that with the system that you're having the problem on and match the security settings up. Now, I've screwed this one up on purpose, so I know exactly how to fix it back. I'm going to go say add users, read access, and replace on all child processes, and say OK, and say OK. Because what was happening is Emmett, let me cancel this out. And now we're going to get our elevation dialog box. And here in a second, we're going to see Emmett's dialog back here. OK. It's coming, I promise. Emmett, where are you? Emmett. Oh, there it is. and here's the dialog box. So I've just fixed that problem, and the way that I discovered it was by looking at process monitor, seeing those access denieds in a way that was very similar to what this user did. There's this count occurrences. There was only one in the trace for the situation he had. Access denied, set the filter. Here's what they saw. Emit conf, reg open key on this value right here, fcags.exe. This key, fcags, is related to McAfee data leak prevention product. So then they tried opening the key. They even tried opening the key from the system process, and it was access denied. This thing was being actively protected by McAfee's own software. So it wasn't even really a ACL problem or permissions problem. It was active defense here in play by McAfee. So we had an exclusion for the McAfee process to emit so that it wouldn't look at that key when it fired up, and that way they got past the problem. So process monitor, looking underneath the hood, seeing access denied, seeing which key, gave them a workaround so that he could have emit continue to work. I know you're still not convinced, so I've got some more. And then hopefully you'll be ready to try that when in doubt line again. Let's take a look at this one. This is a Microsoft support engineer installed for a customer August 2014's cumulative update for Link Server 2013. And what happened was that the diagnostics for Link reported that the logging service was not working. So the engineer went back to the lab and reproed the same situation. Started with the customer's install, upgraded, logging broke. When they went to look at the event log, they found this here, exception, could not load file or assembly, Microsoft.rtc.cls agent IS log. Something here was screwy with this assembly. So they had another system in the lab that was working, that hadn't been upgraded, but it was a clean install. And so what he did was implement a common process monitor troubleshooting technique where you've got one system where it works and one system where it doesn't, and that is side-by-side comparison. And let's go take a look at those log files. Here's the bad log file, and I'm going to open that. I've already filtered it with that for that assembly, and then we're going to compare it with the good log file. You can see a lot more activity in the good log file. What's the bad one doing? What's the failing system doing? It's sitting here looking all over the place for this assembly in all different places. That path not found, file not found. So this thing is just completely missing from this system, and all the nooks and crannies that Link is looking for, it just is not there. Now on the working system, however, you can see that it's found immediately. If I open this up, here, in this directory right here, in GAC, MSIL, Microsoft, blah, 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 and here's that DLL. So it's here on the working system. In fact, on the failing system, it's actually looking in that directory, but not finding it. So engineer takes this DLL from this system, copies it to the other system into that directory. Voila, problem solved. Now, next part of this case, of course, is this a real problem with Link? So he contacts the Link team. Sure enough, it is a real problem with this cumulative update, and there's a little notice about it. By the way, if you've done this and your logging service is broken, download this other update, and the problem will be fixed. So a case where the product itself wouldn't have helped at the time get past this situation, Link logging broken, process monitor, side-by-side comparison, gets the user to a solution where they can fix the problem themselves without having to wait for the product to be fixed like it was. So how about now? Are you convinced? Yeah? So 1, 2, 3, when in doubt, run process monitor. All right, I can tell maybe a little warmer, but still not really with that enthusiasm that I think. So let's take a look at another one. Well, actually, this is a little bit different one. This one, but I'll show you another one in a bit. This one, a user had installed Windows 8, and it's in a network. End user complains to the sysadmin that on one of their Windows 8 systems, they kept getting this dialog box popping up. No matter what they did, they'd log in, and they'd get 2 or 3 of these pop-ups every time after a few minutes of being logged in. And the error message, this is Spanish, no hay aplicaciones instaladas para abrir este tipo de vínculo, CEF error. So that's, here's the correct pronunciation, no apps are installed to open this type of link, CEF error. Question is, where is this coming from? Why is the App Store trying to open an application of type CEF error, or open something that understands CEF-error? Has anybody seen this one before? It's unlikely that you... Somebody? Nobody? Unlikely. Now, they dismiss this dialog box, but they'd still get pop-ups. So really annoying kind of behavior. Again, let's take a look underneath the hood of what was going on here. And so we have the process monitor trace that the admin went to the system and collected. And here's what they found. This log file right here. So here's the full unfiltered trace. And so they simply search for CEF error. And just a little tip. Doing a full text search like this is much slower than just going into the filter dialog box and saying path contains CEF error. That's a much more efficient way to do filtering. But for something like this where I knew that the search was going to be relatively short because the log file is relatively short, I went ahead and did a full text search. Just a tip on efficiency. What we see here is a reg open key on CEF error, and it's coming from this process right here, softonic.exe. The question is, why is softonic.exe trying to open this key? What is softonic doing on the system? Is it something that should be there? Is it something that's broken at this point? So they went and launched Process Explorer, saw that softonic, that at the time of the, all right, so they saw softonic, and what they wanted to do was understand where softonic was getting launched, and that's where they turned to auto runs. Let's take a look at auto runs. So why is softonic getting launched on this system? Now, auto runs is a tool that will scan auto start execution points across the system. Anything that launches when you log onto the system, drivers that launch, Windows services that launch, codecs that launch, service providers that, security providers that launch, print drivers. I've added over the last 20 years, because auto runs was started in 1997, literally hundreds and hundreds of locations, lots of them driven by malware, but auto start execution points where things just get loaded without the user necessarily knowing or even a sysadmin understanding that that's what's happening behind the scenes. I've got here a default filter set which shows us only things that are not from Microsoft or digitally signed by Microsoft. And I'm also filtering out the empty locations. If we want to see everything, simply clear these entries, and now we're seeing everything, including the built-in components of Windows that are also configured in these locations to launch when the system boots. And you see that this list is just enormous. And that's just stuff that's configured. There's many auto start locations that are unpopulated by default on a system. So if we select that back, now we're just looking at things that are not part of Microsoft or Windows or not digitally signed. And we see a much more manageable list. This is really third-party add-ins. Anything in pink is not digitally signed, so something to be concerned about in the case of malware, for example. And anything that's yellow is where it's a kind of broken entry point. This thing, this run key, is pointing at this, has this configured in it, but the path is pointing at some MSIT thing that's broken. So MSIT has deleted this file off my system, but not deleted the auto start location. So this run key is now dangling, has a dangling pointer, which is highlighted in yellow. I can right-click, I can delete the entry, I can copy the entry to the clipboard, I can jump to the entry. So here's where ZoomIt gets started in the registry, and the run key in the registry. I can search online, I can check virus total, I can do a find to look for something here, and I can look at the shell properties for that executable itself. Plus there's some information down here. I can, in auto runs, take a look at other profiles. Very useful for when you have a situation where you want to understand what's configured in other profiles on the system. I can do a filter here. So if I just wanted to see zoom it, and this is a new feature. I've just set a quick filter just to see, hey, is anything zoom it in this list? And there's a way that I can just filter for zoom it. And then just yesterday on the plain right, I added Office extensions, add-ins, at the request of the Office support engineer. And so now you can, in the next version, which I'll update, probably post this week, you'll be able to look at Office add-ins that are configured on your system here. So just to give you an example of how I'm continuously updating this tool. In this case, what they found was this. They found in auto runs, Softonic for Windows, and a web search showed that this thing was actually a download portal. So it wasn't a legitimate piece of software. It was potentially unwanted software that had made this way onto this end user system. For some reason was trying to open something called ceph.error, which caused Windows, the shell, to say, oh, I don't understand how to open that type of file. Let me go search the Windows App Store to see if there's something that understands ceph.error, and that's what comes back with that error, saying nothing there that supports it. So in this situation, it wasn't a matter of working around or fixing that application. It was uninstalling that application, and that caused those problems to go away. So in this situation, in this case, dialog boxes popping up. Who knows from what? Who knows what they're related to? Process monitor showing us underneath the hood that there's this Softonic thing. Auto run showing us how it's getting, this Softonic thing is getting started. And auto run's also able to get rid of the problem. So that's yet another case of process monitor really being the key clue to help unravel this mystery and get the system back into a working situation. This next category is buggy behavior. And I've got an interesting case here. It's the case of the crashing POS application. And this isn't POS as in what you want to call an application that crashes. It really is a POS application, point of sale application. This company had a custom POS application that they'd written in the 90s in Visual Basic. And this is kind of scary. Up until last year, they're running this thing on Windows 98. I think it's only because of the target breach that they said, maybe we should put that thing on a new operating system. So they upgraded to Windows 7. But when they upgraded to Windows 7, the application would crash whenever a user clicked on the payroll hours button. And there's the crash. This case is interesting to me for a number of reasons. One is I love getting these cases from people because many times for a symptom like this, I would have taken a different approach to resolving the problem. I might have done process monitor to see what was going on or used proc dump to look at the crash dump. Every person ends up following a different path through troubleshooting analysis, and the cases that I get sent, of course, are all solved cases. So people are coming up very, very unique ways. In some cases, ways that I'm like, there's no way that that first step would ever lead you to a solution, and then they end up getting to a solution. So this is interesting because this is not the troubleshooting path I would have taken. They went and opened Process Explorer and took a look at the crashing stack. So that dialog box says this process has crashed, and it was sitting there. So the process is there in a dead state with that crash dialog open. They go to Process Explorer and they look at the thread stack, which I showed you a little bit earlier. And remember, we had that hang trying to open it, open the stack dialog of one of the threads. But this was what this person did. You can see that they went, and this TeamViewer service, this process, GTC POS6.exe process, they went to the threads, they clicked on this main thread to look at the stack, and they saw this in the stack. 2 entries here in the stack. Now let me talk a little bit about the stack. The stack you read from bottom up in terms of the execution history of the thread. When one thread starts to execute code, it calls functions. Functions in a DLL that might cause functions in another DLL, and the stack records how the thread gets back to the calling function. So this thread, this function, get TeamViewer interface, called user32 call window proc. So the user32 DLL, this function in it called window proc, called peak message, and so on. And we ended up getting down into here, which then ended up calling here, and the process at that point crashed. I don't think this was the thread that actually crashed, but again, this user took a look at this and said, wait a minute, what's TeamViewer sitting here doing in the thread stack for my POS application? And maybe that can lead me to, maybe that's related to the crash. So this company was actually using a new version of TeamViewer, and so he went to the TeamViewer configuration options and took a look at some of the options there and saw that there was one that would disable a feature that they weren't actually using. So just, hey, I might as well just clean this thing up. Got rid of that Show Quick Connect button on TeamViewer. Went back, ran the POS application, saw that the TeamViewer app was not loaded anymore in the process, and the problem went away. The POS application continued to work. So very interesting case because Process Explorer Thread Stack showed him that there's a third-party DLL inside of their LOB app, POS app, led him to this configuration dialog box where he disabled some unnecessary feature that ended up fixing the problem. It's fascinating the way that the chain of events, and this is why this is such an art and not really a science. I can't give you a recipe for things like that. It really is about exploring and looking for clues that will take you down a path to a workaround or a solution. Now, finally, let's talk about blue screens. How many people have ever experienced a blue screen in the last year? Wow. Okay, so, well, Windows 10 is way better. How many people have ever experienced a blue screen on Windows 10? Oh, okay. I expected nobody to raise their hand on that one. For those watching at home, nobody raised their hand. And Windows 10 is much, much better. But in the past, we used to have blue screens, this blue screen problem. How many people have seen a blue screen in public? Almost everybody. I try to look at the positive side of blue screens in public because you ever walk past a device and it's got some pretty display on it and you're like, I wonder if that's running Windows or something else. Well, when you see it blue screen, you know it's running Windows, and so it makes me proud. All the things that are powered by Windows. So let's go take a look at some of my collection that I've been collecting because people send me these things. Some of you have seen some of these, but there's a bunch of new ones in here. And this is at the SeaTac baggage claim, and this guy's never going to get his luggage, obviously. Here's a DFW. This is Windows update's about to mess with the departure board. This is in Houston. This is a gas pump that has found some new hardware, which is a little frightening. This is a Windows NT. Yeah, this is about 2 years ago. This is the Metro ticket selling kiosk in the New York subway. And here is, the reason I include it is because it blue screened. This is a billboard, blue screening. That package is not going to arrive. This is a popular bar game now. See if you can blue screen the breathalyzer. So if you come across one tonight, try it out. I find it takes lots of drinks to eventually get there. This is a train station in Europe. No wonder we're having job problems. CompUSA's bestseller. Classic. Explains why this company went out of business. This thing wouldn't sell. Sad face at Best Buy. Techno, blue screens. Blue screens are very hip now in the techno scene. This is Dave Solomon, oldie but goodie. This one's fun because he's at the check-in for a flight with his wife on a trip, and she took this picture of him, and he had analyzed the crash by looking at the blue screen and had told everybody in the waiting lounge the reason for the crash. This is Hull Dunkin' Donuts, blue screen. This is a blue screen you can walk on. This another classic. I just have to continue to show this one because it's a classic. This is a gas pump, this blue screen, but here's the reason why. And this is a real picture from the Microsoft Building 26 parking lot. This is a gas pump that is trying to run a Sysinternals tool and waiting for the EULA to be accepted. This is a mall in Ukraine. The kitty care blue screen. This is what they call a bankomat in Ukraine, where if you read Ukrainian, this says bankomat out of order. On MS Paint, this 21 Forever blue screen. That's the most interesting one I've seen. A curved blue screen. Another one on a big building. These people, they're baffled. They're like, how do I get to City Hall? Conference room in Microsoft. This is the gas pump down the street from me. So I fixed this for them. This is now playing in Nashville. Yes, there's still Windows 2000 out there. This is the most public blue screen ever. The Beijing opening ceremony. On the top of that crow's nest or whatever, the bird's nest giant building. This is also another Olympic blue screen. This is in the way into Olympic Park in London. A phone that's blue screened. This is Freedom, I think it's Freedom Tower in Ukraine, in Kiev. This is a ballpark here that is, I would suggest safe mode with networking if I was them. Here. This is a healthcare station. Here's a taxi cab. Check out our latest blue screen. This is another fun game. This one, it's on a highway in Turkey. You see a recent hardware change. It's Istanbul. Insert your Windows installation disk. So this caused a traffic pile-up there, like 3 miles long, as everybody's looking for the installation disk. This one is not, my daughter sends this to me at school, from school one day. She says, this came up at my computer at school. Ha ha. And there it is. So when she got home, I said, well, did you fix it for them? And she said, no, so I made her go do her Sysinternals lessons again. And this is another kind of artistic blue screen. This is modern art. And then oldie but goodie. All right, so that's a quick look at blue screens. That collection is just, I've got hundreds of these now, so it's tough to pick out the fun ones. All right, so blue screens. Let me talk about how relatively easy it is to address many blue screens that you might encounter. And it's as simple as opening up the blue screen in debugging tools for Windows. Here's a case where a user complained on a user group about system crashing. And they say, I'm having a BSOD. I've attached mini dumps. Can anyone help me? So there's mini dumps in here. So somebody opens the mini dump. Let's go take a look at the mini dump and see what they saw. They open the mini dump. And this is how easy it is. Just say Control-D, find the dump file, which is, you can just look in Windows mini dumps or Windows memory.dump. And this case, once the dump has been opened, just click on this hyperlink, Analyze-V. And what that will say is give you a stack, like we saw, and look on the stack to see if there's any drivers that are add-ons to Windows in that stack trace. So anything that's not NT. And sometimes it'll say, we suspect that it was caused by some particular process. In this case, or driver rather. In this case it says, probably called by myfault.sys. Anybody know myfault.sys? This is a Sysinternals tool that I wrote. So if you want to crash your machine on purpose, and there's some cases where people do want to crash machines on purpose. They've become hung and You want to generate a crash dump of it that you can go analyze offline. So you can run not my fault, and there's a few buttons on it that will let you crash the machine. So this person that saw this plea for help in the user group goes and looks at this and says, hey, by the way, are you using Not My Fault by Mark Russinovich? If so, please stop and remove it. You shouldn't be doing that. No wonder you're having blue screens. So the guy's like, well, thanks for the help. I've installed, but it still crashes. True, I used Not My Fault once, but that's not the problem. Here's the new crash dump. So that was a red herring. Let's take a look at the new crash dump that he sent. And again, bang analyze -v. And here we see another driver, ems7sk.sys. Seems to be a likely cause for this, or potential cause for this blue screen. They go and search on the web, and they find this thing is a PCI card reader driver. Windows comes with its own built-in drivers for these, so they uninstall this driver, and voila, now hibernation starts to work. So again, few minutes, open the crash dump, bang analyze -v, look at the stack trace, third-party driver, what is it, uninstall it, or in some cases, go check to see if there's an updated version, and the problem is solved. So speaking of blue screens, this is the modern Windows, this is the reimagined blue screen for Windows 10. We've heard so much feedback about people loving the start menu that we've added it to the blue screen. So now you can interact with the blue screen or with the start menu right from blue screen. And actually, this was in Technical Preview 2. What's coming out in Technical Preview 3 is this one where you can share the blue screen. Social media. And like I said, that's worth upgrading for right there. So with that, I want to thank you very much for coming. I hope you found this useful, informative. I hope, and by the way, before you go, 1, 2, 3. When in doubt, run process monitor. That's good. All right. Thanks for attending. Send me any cases you got, and have a great rest of the conference.